project was to analyze the Menley dataset. The Menley dataset is a set of user document associations without any extra information. In fact, it looks like that. And we wanted to create document clusters from it, but given the sparsity of information, we're fairly limited in the sort of algorithms we can use. And the first thing we did was we tried the k-means algorithm, and the results are plotted here. This is about as expected if you wanted to plot variance versus clusters when you run the k-means algorithm. We looked more specifically at the frequency graph, and the clusters partition looked pretty good, but it's very hard for us to tell exactly how good the clusters are because we don't have any information about who the users are or what the article is. So we wanted to compare our run of the k-means algorithms to something else, and we wanted to try specifically the spectral clustering algorithm, which is an approximation to min-cut. This is slightly more rigorous because if you think about a graph and you think about finding the min-cut, what you have left after you've made those cuts is a bunch of clusters. So there should be a more rigorous way of doing clustering than the sort of arbitrary metric we picked when we wrote the k-means algorithm. So there are 4 steps to spectral clustering. The first thing we want to do is we want to calculate the graph Laplacian. Then we want to calculate the eigenvectors of Laplacian, and then we want to write the eigenvectors as columns, and then we want to compute the k-means of the rows. So if you think about that a little bit, each row corresponds to a different vertex on the graph, and eventually we've clustered all the vertices. So the Laplacian graph matrix looks roughly like this.